Welcome to the Deep Dive. Today we're tackling something universal, something we all experience or think about.
Yeah.
Getting older.
Yeah, it's a process we often just accept, right?
Exactly. And most of us have seen it maybe in loved ones. That familiar arc, the gradual decline. Our source material brings us home with the story of Vera, the grandmother of this Harvard genetics professor we're drawing from. By her mid-80s, he describes her as, well, a shell of her former self.
That's tough.
Yeah. The vibrancy that had defined her gone, he says. Her last decade was just hard to watch. And she'd tell him, this is just the way it goes.
That phrase, just the way it goes, we hear it all the time.
We do. It's this narrative we've completely accepted.
Yeah.
The slow fade, the feeling that the person you knew, well, they'd been dead many years at that point, even before they passed.
It's a somber thought, but it sets the stage perfectly.
It does. Because what if it isn't just the way it goes? What if that decline, the one we see as natural, is actually something else?
And that is the radical idea we're really diving into today. Our mission here is to challenge that fundamental assumption, to redefine what aging even is.
Right. Not just accepting it, but questioning it.
Exactly. We're looking at groundbreaking science suggesting aging isn't just treatable, but that it is a disease itself. Imagine being younger or longer, and not just by a couple of years, but maybe adding decades of healthy, vibrant life.
Decades.
Yeah.
It's transformative.
It is. And we'll definitely unpack the science, the how, and the why, but crucially, we want to bring it back to you, the listener, give you practical insights, things you can think about, maybe even do now, and, hopefully have an entertaining look at where human health might be heading.
A future that sounds, frankly, closer than most people think.
Yeah.
And it promises to redefine what being human even means.
Absolutely.
Our main source, as I mentioned, is this leading genetics professor from Harvard Med, a real leader in the field, offering this unique, almost revolutionary view on biology and lifespan.
He's really challenging those deep-seated beliefs about what our bodies are capable of.
Right. It's a true paradigm shift. Moving away from just treating the symptoms of old age, the heart disease, cancer, dementia, to actually tackling aging itself at its root as the primary problem.
So where do we start with such a huge idea? It feels massive.
It does. We start by confronting what our sources call the blind epidemic.
Okay.
Which means we first have to kind of shake off this ingrained idea that aging is just natural, something we have to accept passively. Look around, maybe in your own family. In wealthy countries, it's common for people to spend, a decade or more suffering through illness after illness at the end.
It's true. Mortality often becomes this long, drawn-out medical experience, doesn't it? Not just stopping.
Exactly. And it's that drawn-out part, that medical experience, that often feels like the real tragedy. The author's memory of his grandmother Vera feeling the person she truly was had been dead many years at that point. That hits hard.
Yeah, that resonates. It's the loss of self, the erosion of personality, joy, movement, cognition that happens long before the actual end for so many.
That deterioration often goes on for years, even decades. It's sobering, but it's that painful reality that really sets up this radical reevaluation we're exploring.
It really does. And here's the core of that paradigm shift, the central claim. Aging isn't just a collection of diseases like heart disease or cancer. It is the primary disease.
The primary one, underlying all the others.
Precisely. Think about it. Since 1893, we've cataloged, over 14,000 causes of death? Our entire medical system, billions in research, it's all geared towards fighting these individual diseases, cancer, heart disease, Alzheimer's.
Right, we target the specifics.
But the source argues that aging itself is the greatest cause of all those diseases. He uses this great analogy. It's like obsessing over why someone fell off a cliff. Did they slip? Did the ground crumble? Was it the wind? Instead of asking the basic question, what brought them to the edge, to the precipice in the first place?
Ah, I see. Aging is the precipice.
That's the idea. It changes everything.
It really does flip the script. If aging is the underlying cause, why don't we treat it like that? Why isn't aging listed as a disease we're actively fighting?
That's the crux of it. And our sources use some really clever thought experiments to help us grasp this and challenge our assumptions.
Okay, like what?
Well, take the line 1 virus thought experiment. Imagine tomorrow, news breaks. Scientists discover this pervasive virus, line 1. It causes this slow, horrible chronic disorder. It's behind most diabetes, drives heart disease, triggers most cancers, causes dementia. Everyone eventually gets it and suffers badly.
Okay. Horrible scenario.
The world would go nuts, right? Governments would pour billions, trillions into finding a cure, a vaccine, total mobilization.
Absolutely. A global emergency.
But the source asks, what if this virus is just aging? Why do we accept its devastating effects just because more than half of all people carry it? Why is that considered natural and inevitable?
Wow. That really highlights the bias, doesn't it? We accept it only because it's universal, our collective blind spot.
Exactly, the blind epidemic. And here's another one. Imagine a world where living to 150 in good health, full vitality, mentally sharp is the norm. Just picture it.
Okay, 150 is the new baseline.
Right. Now, in that world, what if your family member at age 80 suddenly got frail, skin wrinkled, developed diabetes, heart disease, dementia?
In that context, it would seem like a horrifying rare disease.
Precisely. Doctors would diagnose it, name it, study it intensely. There'd be fundraisers, huge research efforts to find a cure. So if we treat it as a disease then, why don't we do that now? What's stopping us?
That question really hits home. Why accept this shorter, sicker life as normal if something better is possible?
And it's not just about alleviating suffering, which is huge, obviously. There's a massive financial angle, too. Treating aging at its core is potentially way, way cheaper than fighting each disease individually as it pops up.
Cheaper. How so?
The source estimates an anti-aging compound, something that extends healthy years by a decade, might cost around $8,790 over a lifetime. Compare that to hundreds of thousands for cancer treatments, or over $1 million for things like pacemakers and the long-term care that follows.
That difference is staggering.
It's a potential fundamental change not just to health, but to economics, saving trillions currently spent managing chronic diseases.
It's an incredible economic point. So if the benefits, both human and financial, are potentially so vast, what's holding back this shift in policy? Is it just perception, this natural aging idea, or are there deeper issues?
It's definitely a mix. Perception is a huge barrier. Our medical system is built around treating specific diseases, clear symptoms, defined endpoints for drug trials. Reclassifying aging disrupts all of that regulations, insurance, trial design. It's a massive overhaul.
The systemic inertia almost.
Yeah, and just basic human resistance to changing long-held beliefs. But, that financial argument is getting harder to ignore.
Okay, so if aging is the underlying disease, the core problem, what's the actual mechanism? The source moves beyond some older ideas, right?
Right. Things like the mutation accumulation hypothesis or the free radical theory. These have been largely, superseded within the scientific community. The free radical idea, for instance, despite being disproven over a decade ago, is still heroin for supplement sellers. Like 60% of U.S. consumers are still chasing antioxidants based on that old theory.
So what's the current leading theory then?
The core concept now is the information theory of aging. It proposes that aging is primarily due to information loss, specifically noise accumulating in the epigenome.
Information loss. Okay, explain that. What's the epigenome again?
Think of it like this. Your genome, your DNA, is like a grand piano with 20,000 keys, the genes. Each key plays a specific note. The epigenome, on the other hand, is the master pianist. It dictates how each key is played soft, loud, held long, played quickly. It orchestrates the music of our lives by controlling which genes are turned on or off and when.
Ah, okay. Genome is the hardware, epigenome is the software or the player.
Exactly. And here's the key difference. The genome is digital information, a stable blueprint. But the epigenome is analog information. And like any analog system, think old vinyl records or cassette tapes.
Or a scratch DVD.
Perfect analogy. It degrades over time. It gets noisy, less precise, falling victim to things like magnetic field, gravity, cosmic rays, and oxygen. This degradation, this noise, is the loss of information.
So the pianist gets less precise. Starts hitting wrong notes or holding them too long.
Precisely. The instructions get garbled, cells start to forget their identity, behaving inappropriately, and this ties back to something called the survival circuit.
Survival circuit. Sounds primal.
It is. Go back 4 billion years to early life forms like M. superstes. They had a basic survival circuit. When their DNA got damaged, say, by radiation, a gene would switch off reproduction and divert all the cell's energy and resources towards DNA repair. Survival first, reproduction later. A huge evolutionary advantage.
Makes sense. Fix the damage before you copy it.
Exactly. Now, we inherited an advanced version of this circuit. When our DNA breaks, which happens constantly just from living specialized proteins, key epigenetic factors called sirtuins rush to the scene. They leave their normal job posts, which involve keeping genes silenced and maintaining cellular identity.
To go fix the DNA break.
Right. But here's the trade-off, the cost of this repair. While the sirtuins are away fixing DNA, the genes they normally keep quiet can get expressed inappropriately. And when they return, they might not always go back to exactly the right spot, or they might land on other parts of the genome, altering gene expression patterns.
So the repair process itself introduces noise into the system. The pianist gets distracted, leaves their post, and things get messy.
That's it. Cells gradually lose their identity, their specialized function. Muscle cells might start acting a bit like nerve cells, skin cells like kidney cells. It's this loss of epigenetic information, this demented pianist playing the wrong music, that drives aging.
Okay, that's a compelling theory. But is there solid proof, evidence that this information loss is really the driver?
Yes, absolutely. Two key lines of evidence really stand out. First, cloning. Think Dolly the sheep, or even earlier experiments cloning tadpoles from adult frog cells.
Right. Taking an old cell and making a new organism.
Exactly. And what does cloning tell us? It beautifully proves that even old cells retain their youthful digital information. The genome itself isn't fundamentally degraded. Clones are not born old. They can be born perfectly normal. This shows the aging process, the epigenetic information can be reset. The blueprint is still there.
So the DVD isn't broken, it's just scratched. Cloning is like polishing it back to new.
Perfect way to put it. And the second, even more direct piece of evidence comes from a landmark experiment with what are called ICE mice, inducible changes to the epigenome.
ICE mice. What do they do?
This was brilliant. Researchers figured out how to age mice prematurely without causing mutations, without shortening their telomeres, without damaging their mitochondria, none of the previously assumed culprits of aging. They simply broke the mice's DNA in places where there aren't any genes. Non-coding regions. This didn't damage the genetic blueprint itself, but it massively distracted the sirtuins.
Pulled them away from their regular jobs to fix these harmless breaks.
Exactly. And the result, these mice aged dramatically faster. Thinning hair, graying fur, bent spines, cloudy eyes, loss of body mass, cataracts, arthritis, even signs of dementia. They were biologically about 50% older than their siblings, living much shorter lives.
Wow. Just by scrambling the epigenetic signals without damaging the core genes.
Precisely. It was powerful proof that this information loss, this epigenetic noise caused by distracting the repair crews is a primary driver, perhaps the primary driver of aging.
Mind-blowing. Okay, so if aging is this information loss, this scratched DVD caused by distracted sirtuins,
yeah,
what can you actually do about it now in your daily life?
Well, the good news is quite a lot. It comes down to activating those ancient survival circuits we talked about, but in a controlled way. It's based on a principle called hormesis.
Hormesis. Okay, what's that?
Hormesis is the idea that a mild kind of adversity, a controlled temporary stress, actually wakes up your cellular defenses. It nudges your longevity genes into action without causing lasting damage.
Like a little nudge, not a massive shock.
Exactly. Think of it as a cellular fire drill. It makes your cells more robust, more resilient, rather than just letting them coast in a state of constant comfort. Our genes didn't evolve for pampered ease. They evolved to handle challenges. This hormesis program is something you can actively trigger.
Okay, how? What kind of mild adversity are we talking about?
One of the most powerful ways is periodic fasting. And the source emphasizes you don't need strict and uncompromising calorie restriction day in, day out. You can get significant benefits just by using hunger some of the time.
So not constant deprivation, but cycles of eating and not eating.
Right. Look at the blue zones, places where people live exceptionally long, healthy lives. Ikaria, Greece, for example. A third of them live past 90. And they follow Greek Orthodox fasting traditions for more than half the year. That often means periods without meat, dairy, eggs, sometimes even oil or wine.
That's significant fasting.
It is. Or look at Bama County in China, another longevity hotspot. Many centenarians there traditionally skip breakfast, eat their first meal around noon. That's easily 16 hours or more each day without eating.
16 hours, that sounds like the 16.8 diet people talk about.
Exactly. That's a popular practical method. Skip breakfast, eat lunch later, confine your eating to an 8-hour window, fast for 16. Or there's the 5.2 diet, eat normally 5 days a week, but cut calories by about 75% on 2 non-consecutive days.
Okay.
Some people do stop eat, skipping food entirely for maybe 1 or 2 full days a week, or more intense versions like Peter Attia's approach of fasting for a whole week every quarter.
A whole week. Wow. Okay, so why does this work at the cellular level? What's happening inside?
It pushes your cells into a beneficial crisis mode. This inhibits a key pathway called mTOR. Think of mTOR as the good time signal. It tells cells resources are plentiful, so focus on growth, build proteins, don't worry about conservation.
But fasting turns that signal down.
Right. It tells cells, hold on, resources might be scarce, time to buckle down, conserve, protect. This shift also activates autophagy.
Autophagy sounds like self-feeding.
Literally, it's your body's internal recycling program. Cells break down and clear out damaged proteins, old mitochondria, other cellular junk. It's like a deep spring cleaning for your cells, getting rid of waste and rejuvenating them.
Okay, so fasting triggers cleanup and conservation. What else triggers hormesis?
Protein restriction, interestingly. Limiting certain amino acids, especially leucine, which is actually added to bodybuilder shakes because it strongly promotes muscle growth.
Because it activates mTOR.
Right.
Signals growth.
Exactly. So limiting leucine and other amino acids also helps inhibit mTOR, sending that same, maybe times are tough, activate defenses signal.
So counterintuitively, maybe less protein sometimes is better for longevity.
The sources suggest so. Limiting meat, dairy, chicken, fish, eggs, especially when you're not needing intense recovery, like after heavy exercise or injury, might be beneficial. It's counterintuitive because we hear so much about protein being essential.
It definitely goes against the grain of a lot of current health advice.
Yeah.
Okay, what about exercise? That feels like an obvious one.
It is, and it's incredibly powerful. Exercise is, by definition, the application of stress to our bodies. And that stress is hormetic.
How does it activate the survival circuits?
It raises your levels of NAD, nicotinamide adenine dinucleotide. We need to talk more about NAD. It's crucial.
Okay.
NAD acts as essential fuel for those sirtuins, the epigenetic regulators. Exercise boosts NAD, which means the sirtuins have more fuel to do their job maintaining the epigenome, silencing the wrong genes, enhancing energy production. Exercise even helps protect telomeres, those caps on our chromosomes, partly through sirtuins like SIRT1 and SIRT6.
So, more NAD means the pianist has more energy and focus. What kind of exercise are we talking about? Just walking?
Walking is great, but to really get these longevity benefits, the source emphasizes vigorous activity.
Define vigorous.
It feels challenging. You're breathing deep and fast, you're sweating. You can't say more than a few words without pausing for breath. Usually means your heart rate is up around 70–85% of its maximum.
Okay, getting properly breathless.
Right. And the effect is profound. Exercise literally turns on the genes to make us young again at a cellular level. It's rejuvenating your cells from the inside out.
Amazing. What about temperature stress? Cold plunges are everywhere now.
Yeah, cold exposure is another form of hormesis. Deliberate cold exposure helps build and activate brown fat.
Brown fat, not the regular white fat.
Right. Brown fat is different. It's packed with mitochondria, and its job is to generate heat by burning calories. Activating it boosts your metabolism and engages longevity pathways, partly by activating a specific sirtuin called SRT3. And yes, adults do have brown fat, especially around the neck and shoulders.
So things like cold showers, turning down the thermostat, maybe even those ice baths, they could actually be activating these longevity genes.
The science suggests yes, it's that mild adversity principle again. And on the flip side, there's heat exposure.
Saunas.
Exactly. Sauna bathing is an ancient tradition, especially in Finland. They say ZOW, not sauna, apparently. And the science is catching up.
What does it show?
There was a remarkable 20-year Finnish study. It found that men who used a sauna 4 to 7 times a week had a 2-fold drop in death from heart disease, fatal heart attacks, and all causes compared to men who used it only once a week.
2-fold. That's huge. Do they know why?
The exact mechanism isn't fully nailed down, but one hypothesis involves a gene called NAMPT, which helps recycle NAD, that crucial sirtuin fuel. Heat stress might turn on NATT, boosting NAD levels. Again, adversity triggering resilience.
So the big picture for temperature is get out of your comfort zone sometimes.
Yeah, pretty much. The source says it does us little good to spend our entire lives in the thermoneutral zone. Our genes didn't evolve for a life of hampered comfort. A little stress now and then, inducing hormesis, likely goes a long way.
Makes sense.
Yeah.
Okay, one last lifestyle piece. Avoiding obvious damage.
Right. This is about minimizing things that directly break DNA and keep those sirtuin repair crews constantly overworked and distracted. Obvious one. Cigarettes. Shockingly, the level of DNA-damaging aromatic amines is 50 to 60 times as high in secondhand as in firsthand smoke.
50 to 60 times, wow. So being near a smoker is incredibly damaging epigenetically.
Hugely distracting for your sirtuins, another big one. N-nitroso compounds, found in cured meats, especially bacon and also some beers.
Okay.
They cause DNA breakage, keeping sirtuins busy with repairs instead of regulation.
So less bacon might be good for your epigenome.
Seems that way. Of course, some DNA damage is unavoidable background radiation, like radon, cosmic rays, maybe mercury in fish. But the idea is to avoid the extra unnecessary damage where you can. Give your sirtuins a break so they can focus on maintaining that youthful information.
Okay, so lifestyle choices, fasting, protein moderation, exercise, temperature, stress, avoiding damage can significantly influence our epigenome through hormesis and protecting sirtuins. But what about interventions? Molecules? Medicines?
Yes, beyond lifestyle, we're entering an era where we can use molecules we call medicines to directly target these aging pathways. It's the cutting edge.
Like what? What are the promising candidates?
One fascinating one is rapamycin. Amazing origin story. Discovered in 1965 in soil from Easter Island, Rapa Nui.
Easter Island? Seriously?
Secreted by a soil bacterium, a researcher named Søren Segal isolated it, named it rapamycin. Initially looked at as an antifungal.
But it became famous for something else, right?
Hugely famous. It turned out to be a powerful immunosuppressant, absolutely vital for preventing organ transplant rejection. It saves lives daily. There's actually a plaque on Easter Island commemorating it.
Wow. And how does it relate to aging?
Its mechanism, it inhibits mTOR, that same pathway we talked about with fasting and protein restriction.
Ah, so it chemically mimics the effects of calorie restriction, telling cells to go into that protective, longevity-promoting mode.
Exactly. It's a CR mimetic. Then there's metformin.
The diabetes drug.
The very same, used by millions for type 2 diabetes, but it also has ancient roots derived from French lilac, Galega officinalis, used medicinally for centuries.
And it has longevity effects, too.
This was a huge surprise. A few years back, researchers noticed diabetics on metformin were living notably healthier lives independent, it seemed, of its effect on diabetes.
A happy side effect.
A massive one. Mouse studies showed even low doses increased lifespan by nearly 6%. That translates roughly to maybe 5 extra healthy years for humans, with an emphasis on healthy.
Healthy years, that's the key. Any other benefits?
Cancer protection seems significant. A review of 26 rodent studies found 25 showed protection from cancer. And human studies suggest up to a 40% lower risk for lung, colorectal, pancreatic, and breast cancer in metformin users.
40% lower risk from a cheap, widely available drug.
As the source puts it. These aren't just numbers. These are people whose lives were markedly improved by using a single safe drug that costs less than a cup of bad coffee. Makes you wonder why it isn't more widely discussed for general health span.
Absolutely. Okay, rapamycin, metformin. What else? I feel like I've heard about resveratrol.
Ah, yes, resveratrol, the red wine compound. It got famous during the hunt for molecules that could extend longevity without hunger. Another CR mimetic search.
Found in grapes.
Yes, and other plants. It was found to activate sirtuins really well, outperforming many other molecules, and it extended yeast lifespan by 30%.
So how does it work? Why do plants make it?
This led to the idea of xenohormesis. The theory is that plants under stress drought, pests produce chemicals like resveratrol to signal their own cells to hunker down and survive.
And we might have evolved to recognize these signals.
Possibly. We eat the stress plant, sense the resveratrol, and our bodies interpret it as an early warning system. Maybe tough times are coming. Better activate our own survival defenses.
Fascinating idea. But the red wine connection, is it real?
Well, here's the catch. To get the dose used effectively in mice, you'd need to drink about 100 glasses of red wine a day.
Okay, so definitely not recommended. More of a proof of concept for the molecule itself.
Exactly. Supplements are a different story, but the wine connection is mostly hype at the necessary dosage levels. Finally, we need to talk about NAD boosters.
Right, NAD. You said it's fuel for the sirtuins.
Crucial fuel. NAD is a central regulator of many major biological processes, including aging and disease. Sirtuins absolutely need it to function, but the problem is NAD levels naturally decrease with age throughout the body.
So less fuel means the sirtuins can't work properly, leading to more epigenetic noise.
That's the connection. But there are precursor molecules that can boost NAD levels. The main ones studied are NMN, nicotinamide mononucleotide, and NR, nicotinamide riboside.
Where do you find those?
They're in foods like avocado, broccoli, cabbage, but in very small amounts. Supplements are being heavily researched.
And what do they do in studies?
The results in mice are pretty striking. They've restored symptoms of type 2 diabetes, made the mitochondria in old mice function like young ones in just a week. Real signs of cellular rejuvenation.
A week? That's fast. What about humans?
Less large-scale trial data yet, but the anecdotal evidence is compelling. Our source shares a very personal story about his own father.
Oh, yeah.
Describes him as skeptical, an Eeyore from Winnie the Pooh who expected to end up in a nursing home like his own mother. He started metformin for borderline diabetes, then added NMN. The transformation was apparently remarkable. He went from pessimism to waking up every morning with a deep-seated desire to fill his life with new, exciting experiences. Started traveling the world, took up new hobbies, even started a new career in his late 70s.
Wow. That's more than just living longer. That's living better. Fuller.
Exactly. Extending vitality. There are also some controversial but interesting anecdotal reports of NAD boosters restoring menstruation in postmenopausal women, even fertility in old horses. Hints at a deep biological reset.
So the idea is that NAD boosters help suppress epigenetic changes, maintain the youthful program, reduce that informational noise.
That's the mechanism, helping polish that scratched DVD by providing the fuel for the maintenance crews, the sirtuins.
Okay, so we have lifestyle changes, powerful molecules. Where is this all heading? What does the future look like? It sounds like a total medical revolution is underway.
It really is. We're talking about developments that could redefine health and society. One area is targeting zombie cells with drugs called senolytics.
Zombie cells. Sounds ominous.
They are officially called senescent cells. They accumulate with age, they stop dividing, but refuse to die, hence zombie. And worse, they secrete inflammatory stuff that damages surrounding tissue, promotes cancer, and can even turn other cells into zombies.
Yikes. Like a bad influence spreading.
Exactly. Inject just a tiny dab under a young mouse's skin and it causes premature aging. Senolytics are drugs designed to specifically find and kill these zombie cells, trigger their self-destruct. Human trials started in 2018 for things like osteoarthritis and glaucoma. If they prove safe and broadly effective, the potential is vast.
Clearing out the cellular deadwood, essentially. What else?
Perhaps the most, fanciful idea, but one rooted in solid science now, is cellular reprogramming, the ultimate reset.
Reprogramming cells. How?
Using what are called Yamanaka factors, a set of genes like OCT4, SOX2, KLF4. Expressing these in adult cells can effectively reset their epigenetic clock, turn them back to a more youthful stem cell-like state, polishing the DVD directly.
Is this actually possible?
It's happening in labs. Our source describes this incredible moment, seeing images from a grad student's work regenerated optic nerves in mice. Nerves that had been crushed were growing back, looking like orange glowing jellyfish connecting to the brain.
Regenerating nerves in middle-aged mice.
Yes, he called it the greatest example of nerve generation in history. If this can be made safe for the whole body, imagine regrowing any other kind of tissue damaged by age. From the liver to the kidney, from the heart to the brain, nothing is off the table.
That's unbelievable. The end of organ failure from aging.
Potentially. It's truly revolutionary, and underpinning all this will be precision medicine and personal biosensors.
Getting much more personalized.
Massively. DNA sequencing can already tell you what foods to eat, what microbiomes to cultivate, what therapies will work best for you.
Like pharmacogenomics.
Yeah.
Knowing how you'll react to drugs.
Exactly. There are already pharmacogenetic labels for drugs like Coumadin, Plavix, even antidepressants, where your genes predict your response. The source tells a story about his mom having a bad reaction to digoxin, and his biochemist dad realizing it was an overdose because her genetics made her super sensitive. Soon, prescribing a drug without first knowing a patient's genome will seem medieval.
Tailored medicine. What about detecting disease earlier?
Game-changing developments there, too. Blood tests using circulating cell-free DNA or cfDNA. They can find tiny fragments of tumor DNA floating in your blood, detecting cancer years before they can normally be detected.
That's earlier.
Yes, and often they can even tell you what kind of cancer you have and how to kill it. Plus, things like breath tests for lung cancer are emerging. Early detection completely changes outcomes.
And day-to-day monitoring.
We know more about our cars than our bodies, right? That's changing with personal biosensors, watches, continuous monitors. Imagine getting real-time data. Your blood sugar is high after breakfast, you're low on iron, you need vitamin D.
And AI helping you manage it.
Yeah, AI assistants guiding food choices, arranging healthy meal deliveries, making truly data-driven day-to-day health decisions. Biotracking has already shown it can lower blood sugar as efficiently as the leading diabetes drug. It's proactive, personalized health management.
It sounds like science fiction, but it's a writing. So what does this mean for society as a whole? Huge transformations ahead.
Massive. Concerns about population and resources are valid. We're at 8 billion people. Many scientists worry about carrying capacity.
Right, the Malthusian trap idea.
But the source pushes back against simple linear thinking. Humans excel at acquiring and passing on learned skills. Innovations allowing us to feed more people, reduce disease, extend healthy lives. He argues these are natural human progressions.
We innovate our way out of limits.
Often, yes. Look at Las Vegas. Population grew hugely, but water use fell by 1/3 due to tech and conservation. LEDs save massive energy. CRISPR-edited crops could feed 1 billion more people with more nutritional food, potentially preventing millions of deaths from vitamin A deficiency, something scientists are actively tackling.
And there's a historical example.
London in the 19th century. Overcrowded, cholera, squalor, seemed doomed. But the source says the disease was the cure. The crisis forced innovation. Public housing, sanitation, public health infrastructure. Today, London has 3x the people, but far less death, disease, and despair. We adapt.
That's a hopeful perspective.
Yeah.
What about work and retirement if people are healthy for decades longer?
The whole concept has to change. Retirement at 65 seems absurd if you're healthy and vital into your 90s or beyond. Think of Harriet Thompson running marathons at 91. Older workers often outperform younger ones in most mental tasks, writing and vocabulary and leadership. Experience counts.
So more productive years, potentially. How do social systems adapt?
Social Security was designed when few lived long past 65. What if 65 is just the midpoint? Ideas like skill sabbaticals, paid time off for retraining might become normal. People can pivot, learn new skills throughout a much longer career arc.
And personal freedom.
Huge implications. If you know you can likely stay healthy and work if you choose to, the fear of outliving your savings diminishes. Spending money on a dream, starting a late-life venture, it shifts from a huge risk to an investment in a long and fulfilling life.
Doesn't this raise huge ethical questions?
Yeah.
About access,
Yeah.
wealth disparity.
Absolutely. That's a critical concern. The risk of a Gattaca-like scenario, a world of haves and have-nots, where the wealthy can buy an extra 30 years of healthy life through access to stem cells, hormones, gene editing. It's real.
Exacerbating inequality massively.
Potentially, yes. It forces us to ask, if technology can repair a child's damaged eye or spine before an accident, should it be delivered preemptively, ready to be switched on? What are our moral obligations to ensure these life-altering technologies are accessible to everyone, not just the rich? These are urgent conversations we need now.
Deeply complex ethical territory. Finally, what about the human spirit? People often say they wouldn't want to live too long.
Right, you hear that just shoot me at 100 sentiment, but the source argues people aren't afraid of losing their lives, they're afraid of losing their humanity, ending up frail, demented, kept alive artificially like that grandfather zapped back to a vegetative state.
So the goal isn't just more life, it's more healthy life.
Exactly. Healthy life extension. Living fully, then dying quickly and painlessly when they are ready, on their own terms.
Maybe, as Seneca said, if we're not constantly afraid of the ticking clock, we'll actually slow down and appreciate time more.
It's possible. And think about the accountability. Generations upon generations living together, working together, making decisions together. We'll be accountable in this life for the decisions we made in the past that will impact the future. We'll have to look our great-grandchildren in the eye.
A profound level of intergenerational connection and responsibility.
A completely new dynamic for society.
So wrapping up this deep dive, we've gone from seeing aging as inevitable decline to understanding it as a disease of information loss, something potentially treatable.
Yeah, from the theory to practical lifestyle changes, revolutionary molecules, and these mind-blowing future technologies like senolytics and reprogramming.
And this isn't just sci-fi speculation. A vast and brilliant army of researchers is making huge progress now. It's about more than survival. It's about prolonging healthy life. Vibrant, purposeful life.
The focus is shifting profoundly from just adding years to adding quality to those years, adding health span.
So the final thought for you, the listener, with significantly prolonged vitality becoming a real possibility, maybe even an inevitability.
Yeah.
What do you want that future world to look like? And, more personally, what will you do with all those extra healthy years?